Hi, so myself Dr. K. Hemalatha. I'm working as an associate professor in Mlritm. So today my topic is dielectric materials. So in this dielectric materials already we have discussed the introduction part. So in this dielectric materials first we have discussed the what are the differences between the dielectric materials and insulators. So in dielectric materials, so in the presence of the external electric field, we are observed some very different phenomena. That means it is forms the electric dipoles are created in the presence of the electric field. But in all dielectric materials are insulators, but all insulators are not behave like as a dielectric materials. Already this one is were discussed. And what are differences between the insulators and dielectric materials, and next some basic points about the dielectric materials are also we are discussed. And next types of the dielectric materials, who have the solids and liquids and gases dielectric materials are there, and some examples are also we are discussed, and some basic definition. This is very important. So electric dipole and what is the meaning by dipole momentum, and dielectric constant and polarization. So polarization, just once you have to recall this one. So in the presence of the electric field, all are oriented along the field direction. The positive charges are oriented along the field direction in the presence of the electric field. So entire the material will observe some electric dipoles are created. So which materials you have to observe this dipoles are create this phenomena, that materials are called the dielectric materials. So polarizability also we are discussed, and electric susceptibility. So all materials have the susceptibility value is greater than 1. So that the dielectric materials have the susceptibility value is always positive only. So this is discussed. So now we have to start the topic, the types of polarizations. So in dielectric materials we observe the 4 kinds of the polarizations. So one is the electronic polarization, and the second one is the ionic polarization, and the third one is the orientational polarization, or we have to call the other name is dipolar polarization also, and the next one is the space charge polarization. So these polarizations were observed in the dielectric materials based on the different materials. That means, so first in ionic polarization. So what is the meaning by ionic polarization? So coming into the ionic polarization, when electric field is applied to an atom, the positive charged nucleus is displaced along the electric field direction, and the negatively charged cloud is the opposite to the field direction. These kind of displacement were observed. Then what happens means electric dipoles are created within the atom. So here in the electronic polarization, especially we have to observe in the atoms. That means here we have to, in atoms, the substance we have to place it in the electric field. Then what we are observed means the positively charged nucleus is oriented along the field direction, and the electronic cloud moves the opposite to the field direction. That means negatively charged cloud is oriented the opposite to the field direction. So these kind of polarization were observed. So this is called the electronic polarization. So here we have to consider one atom, and this dipole momentum is also proportional to the magnitude of the field strength. So we have to increase the field, then the dipole momentum is also increases. So here we have to consider one atom. So here this is the nucleus. Around the nucleus are electrons are revolved. So these all electrons are we have to consider as a electron cloud. So in the presence of this is the without electric field. So whenever field we have to applied in this direction, field is applied in this direction, then the nucleus is along the field direction. Actually nucleus it is not moves. So nucleus is it is weight part. That means why? Because nucleus it is consist of the protons and neutrons. So that's why the nucleus it is not moves, not moving. So it is in the same place, but electron cloud, so electric field and electron cloud are same charges. So it is repels opposite to the field direction. So this is the electron cloud and this is the nucleus. In the presence of we have to observe in the electric field, it is forms like as a dipole. So this is the distance D, nucleus and electron cloud. So these type of polarization is called the electronic polarization. So the dipole momentum of electronic polarization we have to taken with the symbol of mu suffix e. Mu e is directly proportional to the applied electric field. So here we have to remove the proportionality constant. We have to take in the alpha e. So this is called the electronic, alpha e is called the, this constant is called the electronic polarizability. Electronic polarizability. The examples of this electronic polarization we have to observe in the helium, neon, etc. So in the presence of the electric field, the atoms are created like as a dipole. So that is this type of polarization is called the electronic polarization. So and next one is the ionic polarization. So dielectric materials in the form of the molecules. Then what happens? How we are observing the polarization in this type of dielectric materials? So here in ionic polarization. So in the ionic polarization, so whatever it may be, polarization is occurs in the presence of the electric field only. So here whenever you have to apply the electric field to the ionic dielectric material, the positive ions are moved to the field direction, and whereas negative ions are moved to the opposite to the field direction, then the dipoles will be formed. This type of polarization is called the ionic polarization. This type of polarization is called the ionic polarization. Examples are NaCl, KCl and KBr. So these are all the examples. So here you have to consider one example, that is the NaCl molecule. So this NaCl molecule you have to take in without electric field. Without electric field, the NaCl it is forms like as a, this is the Na plus and Cl minus. So in the presence of the, whenever you have to apply the electric field, these NaCl and Cl minus it is forms like as a ions. So Na plus Cl minus are divided by some distance, so some displacement. So then you have to observe the dipoles. We have to observe the Na plus and Cl minus. So it is displaced from their equilibrium position. So this kind of polarization is called the ionic polarization. The examples are NaCl and KCl. So for example, here we have to discussed already. We have to take in the ionic bond structure of the NaCl. So whenever we have to apply the electric field, it is forms like as a Na plus Cl minus. Cl minus ions displaced from their equilibrium position in the opposite direction to each other. So this ionic polarization is directly proportional to the electric field. So whatever it may be, you have to observe the polarization. It is mainly depends on the strength of the electric field. The strength of the electric field. So ionic polarization. So we have to take in P suffix I. It is directly proportional to the external applied electric field. So we have to increase the field. The polarization is also increased. That means the dipoles are created more and the displacement is also increases. Then, so the P is Pi is directly proportional to the electric field. So you have to remove the proportionality. You get one constant, that is the alpha I. Alpha I. So this is called the ionic polarizability. Alpha suffix I. So Pi is equal to alpha I into E. So here alpha I is called the ionic polarizability. So here we have to take in the n molecules, then the polarization is given by Pi is equal to n alpha I into E. So n is the number of the molecules in that dielectric material. So it is the polarization is depends on the number of molecules, and then mainly it is depends on the applied electric field strength. So this type of polarization is called the ionic polarization. So in the electronic polarization, we have to consider as a atoms. In the ionic polarization, we have to take in the dielectric material in the form of the molecules. So this is the ionic polarization. And the next third one is the orientation polarization, or we have to call other name is the dipolar polarization. So here, how we are observed this type of polarization means, so here also we have to apply the external electric field only. So polarization basic definition, it is explains the in the presence of the external electric field. So whenever we have to apply the electric field, how we are observed the polarization. So coming into the orientation polarization, so this type of polarization occurs in the polar substances. Polar substances means already the electric dipoles are existing in that materials, in that dielectric materials. But the net dipole momentum we have to calculate, it is moving in the random direction. So we have to calculate the net dipole momentum. That value is equal to 0. So whenever you have to apply the electric field, what happens means the dipoles are oriented along the field direction. This type of polarization is called the orientational polarization. Orientation means already dipoles are existing. Whenever you have to apply the electric field, all dipoles are oriented. Orient means it is change their direction in the field of the electric field. This kind of the polarization is called the orientational polarization or dipolar polarization. So here once you have to observe this type of polarization occurs polar substance. Polar substance means already the dipoles are exist in that material, which shows the dipole moment in the absence of the electric field. So they are moving in the random orientation. The net dipole momentum value is 0. So whenever we have to place that polar substance in the presence of the electric field, what we are observed, the dipoles are rotate about their axis of symmetry, and it is aligned with the field direction. So here we have to take in some example. This is one substance. So already in this substance, the dipoles are created positive and negative, but it is in different direction. That means it is moving in the random axis. But it is the E is equal to here 0. Means there is no external electric field. But the dipole momentum is there. But we have to calculate the dipole momentum. That total value, it is equal to 0. Why? Because it is moving in random direction. So whenever we have to apply the electric field, then all are oriented along the field direction. So that means all positive charges are along the field direction, and negative charges are opposite to the field direction. So here in the presence of the electric field, the dipoles are oriented along the field direction. This kind of polarization is called the orientational polarization. So here orientational polarization we have to indicate with the P suffix O, orient, polarization of orientation polarization. It is also directly proportional to the electric field. That means field strength. So we have to remove the proportionality. You get one constant that is equal to alpha O. Alpha O. So this is called the orientation polarizability. Alpha naught is called the orientational polarizability. So examples of these polarizations are methyl chloride molecules. They exhibit the already polar dipoles are existing. Whenever you have to apply the electric field, then we have to observe the all are oriented along the field direction. So this type of polarization is called the orientational polarizations. And the next last one type of polarization is space charge polarization. Space charge polarization. So this polarization we have to observe. So the tendency of redistribution of charges in the dielectric material in the presence of the electric field. So already the the charges are like as a dipole, but whenever you have to apply the external electric field, the tendency of redistribution, it is redistributions along the field direction, So here we have to observe there is no electric field, all charges are it is in randomly. So whenever you have to apply the electric field, so here also all are they change their tendency of redistribution. That means all are oriented along the the direction of the electric field. All positive charges are moves to the field direction and negative charges are opposite to the field direction. But we have to observe these polarization value is very small, it is negligible. So that's why this space charge polarization is not considered. But polarization is occurs in the presence of the electric field, but that is very small amount. So that is very small. So these type of polarizations are not considered. But this is also one type of the polarization. So this is called the space charge polarization. So we have the total 4 types of polarization. One is the electronic polarization. This polarization we have to observe the material, the dielectric material, it is forms like as a atoms. Then that type of polarization is called the electronic polarization. So the dielectric material, it is in the form of the molecules. Then that type of polarization is called the ionic polarization. So we have to apply the electric field. And another one is the orientation polarization. In this polarization, already the dipoles are existed. Whenever you have to apply the electric field, then the dipoles all are oriented along the field direction. And next is the space charge polarization. In this space charge polarization, the charges they change their tendency of redistribution then along the field direction. This type of polarization is called the space charge polarization. So here this is we have to in the space charge polarization, the values are we have to taken 0. Why? Because it is the alpha PS is directly proportional to the E. So we have to remove the proportionality constant, that is alpha S E into E. So this alpha S value is very small. So that is negligible. So that's why this polarization is not considered. So the main polarizations are electronic polarization and ionic polarization and orientational polarization. So these are all the types of polarization. And the next session we have to discuss the another topic, and these are all my references. Thank you.